Only 1% of all of the water on the planet is fresh, usable water, and it's found in our lakes and rivers. I'm Alan, and this is Stephen, and together we work for an organisation called CatchmentCARE, who study and look after some of our rivers. We set out on a journey to explore 3 rivers, the Arnie, the Blackwater and the Finn, and along the way we met some amazing people who are taking care of them, and some of them doing mind-blowing science to help them. We got to see some incredible places, some super sights and fantastic creatures. And most of all, we learned just how important our rivers are. Do you want to find out more? Then welcome to the river. Hello, and welcome to the river. Over the next few programs, we're going to be taking you on a journey to explore more of this, the river. Rivers are everywhere, and so often we forget about them. It's just a bunch of water running through the countryside, or maybe through your town or your village, but we don't know an awful lot about them. So what we're going to do is we're going to take you and show you more of this.
And in today's episode, we're going to be looking at where a river comes from. We're going to be making a rain gauge, and we're also going to look at the difference between salt water and fresh water. But first, have a look at this. Alan, here's a question. Where does water in a river come from?
Oh, that's a good question.
Good question.
It's complex, but we only get one set of water in the world. We don't get any new stuff. So it has to be cycled round and round and round, and we call that the water cycle. Now, it all starts with this big orange ball in the sky. Do you like my drawing, by the way?
You are so artistic. You really are. I like your mountains and your sea. And
gorgeous.
Oh, very, very good. On. So this is the sun.
And it gives heat energy to the water in the seas and the oceans, and it gets very excited. It gets lots of energy, and it rises up. That's called evaporation.
That's when the energy from the sun turns some surface layers of the ocean there into a wee gas, like water vapour.
Correct. Does it remind you of anything?
It reminds me a little bit, I think, of boiling a kettle.
Exactly right. Same process. And when it gets up there, if you think of the steam of a kettle and it might hit a cold glass window or something, it starts to make wee droplets on the
droplets of water on the window.
That's condensation, and it's the same process up in the cold atmosphere. It starts to condense. All those little water droplets condense into big white fluffy
clouds.
Sheep.
Yeah. Sheep.
Then the wind blows those across the land, and it starts to gather more and more droplets of water as it gets over there. And the heavier the clouds get, the darker they become.
Like a black sheep.
Like a big black sheep.
A big black sheep.
What's going to happen now, Stephen?
Well, I would say or suggest those clouds then can't hold those water droplets, so
Correct.
the only way of getting rid of them is to pour them out.
Pour them out.
But like precipitation, is that the word?
Is the word. And that can be rain or sleet or snow or hail. But anyway, it falls onto usually high ground, but of course it covers all of the land. So, sun, evaporation, condenses into white clouds, blown across the land, and of course then we get the precipitation on the high ground. Now, all of that water is gathered then, because that's what we call a catchment. It's that big area that gathers the water together. And it gathers it in wee streams, or what we call tributaries, at the early stage of a river. And those wee streams all gather the water together, and it starts to flow down the side of the mountain, and then into the mature stage of the river across the land, till it gets to the old stage of the river and it meets the sea again. And so it keeps going. It's cycled round and round and round. So it evaporates because of the energy of the sun. It condenses into white clouds, pushed across into big grey clouds, and it rains. Down the river it goes and back out to the sea. That's the water cycle.
Excellent. Well, what about rainfall that might fall directly onto the ground?
Okay, yeah. Well, now that's really interesting because, of course, not all the rain falls on high ground. It falls everywhere. What happens is it filters down through the ground like this, through the land, through the soils, and into the bedrock, where it gathers together in big stores, like big basins of water, and we call that groundwater. So once it's filtered down there, It sits there in tanks. Now, sometimes it doesn't go right down to the bottom. Sometimes it gets into the grass or into the soil and then is channeled straight back into the rivers.
Excellent.
Which is why there's always water in a river somewhere. They never really...
Never run out.
Never run out, never dry up.
I've come into the kitchen to do an experiment with water. Water is the most important element on the planet, and I can say that because without water there is no life. That's why NASA spends millions of dollars every year sending satellites up and taking pictures of Mars, because they know that if there's water on Mars, if there ever was water on Mars, then there's got to be life on Mars, or there was life on Mars. And it's the same here on Earth. All of the living creatures and living things on Earth need water. Your body, in fact, is made up of 60% water. 60% of this is just water. That's why it's really important to keep drinking water and eating fruits and vegetables, which are mainly water. Things like apples and pears, which are 95% water, and tomatoes, which are 94% water, and a cucumber, which is 90% water. Water is vital to life. Now, 98% of our water, which is almost all of our water, can be found in our seas and our oceans. 2% of the water is fresh water. 1% of that is locked up in all of the ice and the glaciers and a thing that we call the permafrost, which leaves us 1% of all of the water on Earth, on the planet, that we can use. And it's found in our rivers, it's found in our lakes, and our ponds, and in the atmosphere. 1% of all of the water on the planet. That's why it's important to look after it, to turn the tap off when we're doing the dishes, to turn the tap off when we're cleaning our teeth, to have a shower rather than a bath. Water is essential to life, and we don't have a lot of it. So water comes in 3 states. It comes as a solid, a liquid, and a gas. And we call those 3 things ice, water, and steam. And it's all to do with how much energy it has. So if we take all the energy out, or take the heat out of water, it will become solid and it will become ice. If we give it a little bit of energy, in other words, leave it out in the nice warm air, it'll become a liquid. Liquids, by the way, are the things you can pour into something. They pour in and they take the shape of whatever you pour them into. So this water has taken the shape of the glass. This water has taken the shape of the jug. The water in the pipes has taken the shape of the pipes. Give that even more energy, in other words, put it into a kettle and give it heat energy, and that will evaporate and become a gas.
Before we do the experiment, it's craft time. Maybe you want to try this in the class or at home.
We're going to do a simple activity called making a rain gauge. And we don't need too much equipment to do it. I'll go through it quickly now. Main thing we need, main source of material, is a bottle. Okay, a plastic bottle, but a 1.5 to 2 litre size bottle. We need a ruler. We need some type of permanent marker. A pair of scissors. Some little stones, and we'll talk about that shortly, and also stapler. Okay, we'll be putting some water in it as well, but I'll explain that when we get to it. Now, the first thing we have to do is create a little hole in our bottle and cut the top off it. Now, we normally cut about 1/3 of the way down. It's very useful if you're doing this at home, have an adult start this off, okay, because it can be quite difficult. Now, let's just see if I can do it here. Okay, so my scissors are in, be very careful. I'm just going to cut around, taking my time. And there we go. Okay, so I'm going to bring this close up to the camera. We have now created our measurement for our rain gauge. Okay, and it's in centimetres. And as you can see, we've got it from 0 up to 10. Okay, now the 0 point is marked on the baseline, and I'm going to show you how to draw that in. Okay, now normally the baseline is at the bottom of the bottle, and there's normally a line for a little indicator to help you. Okay, we're going to show you how why this is really important in a minute, but let's just mark it first. Okay, it's just here, going round. Okay, here's some stones that I got from the garden. Easy to get stones from anywhere, and we're just going to add them into the base. And the reason we do this, okay, is just to give our rain gauge a little bit of support, because we don't want it blowing over if there's a lot of wind. Alright, so this will keep it steady and secure. Okay, just a handful of stones, and that's it done. The other thing we need to do to finish a rain gauge off is to put a nice funnel into it. Okay, so the part of the bottle that we cut off earlier, the top third, we're going to secure it in like this. Okay, just sitting down, but it could blow out. So what we'll do to make it a bit more secure is just to add a few staples. Alright, so we don't need lots of staples, just a couple. We've got one, and we're going to have another one around here, and we'll just put one more in. Okay, so there we have our rain gauge almost complete. Okay, I'm going to add some water, right? Add water to our rain gauge, and we're going to fill this up to baseline. Now the baseline is indicated by 0 on our measuring line. And you might say, well Steve, what's the point in doing that? Surely the rain could fill that up. But the actual point is that we want a flat, even surface to begin with, where we can measure from. If you look at the bottom of the bottle, you'll see it's not flat, there's wee indents in it. Okay? So we want an accurate reading, and to do that we have to create a baseline. And that's it done.
So I'm now going to do an experiment to see the difference between fresh water and salt water. Now, if you were to look at fresh water under the microscope, you would see it's made up of lots of different molecules, and each molecule is made up of atoms, 2 hydrogen and 1 oxygen stuck together, and that gives us H2O, or water. Salt water is slightly different in that you've still got the H2O, but you've also got 1 sodium molecule and 1 chloride molecule, NaCl plus the H2O. That's salt water. Now we can do an experiment that will show us that. So let me show you the equipment that we've got. I have 2 large test tubes, but of course you can use an ordinary drinking glass or a couple of drinking glasses for this if you're doing it at home. I have an egg, just an ordinary egg at room temperature. It's not boiled or anything. I have a jug of 200 millilitres of water. I have a dessert spoon. I have some table salt, some ordinary salt, NaCl. And I also have some food colouring, but that's just to show you the difference between fresh water and salt water later on, so we'll see that later. Okay, so let's see what happens if we put the egg into fresh water first of all. This is just ordinary water from the tap, 200 mils, and we're going to put it into the test tube. There it goes, 200 mils. We take the egg and put it into the test tube. Now look at that. Straight away, sinks straight to the bottom. Very interesting. Okay, let's try the experiment again, but this time we will add salt to the water. So I'm going to take my 200 millilitres of water, pour it back into my jug, take my egg out, set it to the side. And this time I'm going to add 2 dessert spoonfuls of salt to the water. Dissolving, I'm going to add some food colouring. This is to tell me that this is salt water, and to show me that it's salt water, not fresh water, I'll add a couple of drops of food colouring. So, I'm going to put the water into this test tube, 200 mils. There we go. Same egg into the water here this time. This time, the egg floats in the salt water. Isn't that interesting? So what's happening? Well, in the fresh water, we've only got H2O, and water always takes the shape of the thing that we put it into. And in this case, there's an egg in there, so the water flows around the outside of the egg, and the egg sinks. But with the NaCl, or the salt, in the water, the water doesn't flow around the egg and actually holds it up. So we've got an egg that floats in the test tube. Now, I wonder what would happen if we mixed the two together. If we put the salt water in first of all and floated the egg on top, and then we added fresh water, can you estimate, can you think what might happen? Will it float right to the very surface? Will it stay in the middle between the fresh water and the salt water? Or will it sink right to the bottom? What do you think? Well, let's do the experiment and find out. Okay, so I'm going to take my test tube of salt water and I'm going to pour half of it out. Make sure my egg doesn't come out. And we'll do a bit more. Yeah, that's enough. Okay, and we'll pour that out. And we'll get some fresh water and we'll add it to the top and see what happens. So it might float to the top, it might stay where it is, or it might sink to the bottom. Here we go. Adding the fresh water. How cool is that? So now we have a layer of fresh water on the top, we have the egg in the middle, and we have the salt water at the bottom. If you said that it would float in the middle, you're dead right.
So now that we've made our rain gauge, we're going to now create a graph so that we can measure the rainfall over the period of a week. Now, let's take a look at how we're going to construct our graph, sometimes referred to as a histogram. So we've got our graph paper and we're going to now label the axis. So along the side, we're going to put centimetres, as in centimetres that was on the rain gauge. So each of these squares is going to represent 1 centimetre going upwards. Okay, so I'm going to draw that first. So just use your ruler. We make sure it's lined up nice against the line. Start at the bottom and we're going to go straight up. Just like this. Nice black pen's good, or else a pencil. Let's do this. Okay, so this is going to be centimetres, as in centimetres of rainfall. So we'll call it CM or CMS for centimetres. And then we'll start at the bottom and label the bottom 0. And then we're going to go 1, 2, 3, 4, and this will go on until 10. Okay, along the bottom we're going to have days of the week, because we want to measure the rainfall over a period of say 7 to 8 days. Okay, so we'll have, this one's going to be day 1 of day 1, and then this little square is going to be day 2, day 3, then we'll have 4, 5, 6, 7, and 8. So we can do it over a period of 8 days. So it's day 1. Let's go and take a look how much rain has fallen. And we just wait for the rain to settle, the water to settle, and there is about 3 centimetres of rain that has fallen. Okay, what I want to do now is record that on our graph. So if I remove this out of the way, so we've got our graph. So 3 centimetres in day 1. So I go up to 3, across, and we'll just draw it down to the line where day 1 ends, and that's our reading for day 1. One thing you must remember is to empty out the water so it's back to 0 for the baseline reading for tomorrow. So on day 1 we had 3 centimetres of rain. Yesterday we were down a little to 1 centimetre. Let's see what we have today. So there was no rain yesterday. We have 0 on our rain gauge. So when we go to our graph, that's going to be 0 for day 3. This is our final day and our reading is 4 centimetres of rainfall. Alright, let's just see this on our chart. So as you can see, we have our chart nice and neatly coloured in, and our final reading on day 8 is 4 centimetres of rainfall. Now, a few things just to remember when we're doing these charts, okay? It's good to have a title. So we can call ours rainfall for an 8-day period, or rainfall over a period of a week, okay, if you want to do that. As you can see, I'm just having a wee look at the graph there to see if there's any patterns, but one thing I do notice is the range of rainfall. And the least rainfall we had was on day 3, which was 0, and the most we had was on day 6, which was 6. So a rainfall range for the 8 days was 6, 0 to 6. So there you have it. Now we know where water comes from and the different methods it takes to get into the river channel, whether that be through the ground, through the soil, or simply over the surface of the land and into the river. All that water then is carried down to the ocean. So why don't you tune in next time to see how the river changes the landscape.